Welcome all in the second lecture of the Fourier integral representation. Today we are going to discuss one more problem. Question is, find the Fourier integral representation for the function f of x is equal to 1 minus x square in the interval mod x less than 1 and is equal to 0 in the interval mod x greater than 1. Now we have seen that the Fourier integral representation is f of x is equal to 1 upon r integration from 0 to infinity, integration from minus infinity to plus infinity, f of s into cos of omega into bracket s minus x d omega ds. Now here f of s will be 0. We are taking the same values from here. We are replacing x by s. So f of s will be 0 in the interval minus 1 to minus infinity to minus 1 and 1 to infinity. In this interval this function is 0 and is equal to 1 minus x square in the interval minus 1 to 1. Just a minute. 1 minus x square. Here we are replacing x by s. 1 minus s square is equal to minus 1. Now you can observe 1 minus s square, f of s is equal to 1 minus s square defined in the interval minus 1 to plus 1 is an even function. See, I have already told the definition of even function. If I replace s by minus s, we get minus s square. Minus s square will be plus s square and the minus s is already outside. So we get f of s as same if I replace s by minus s. So we say that f of s is equal to 1 minus s square is even in minus 1 to 1. Therefore, by Fourier cosine integral representation, the f of x is given as 1 upon pi integration from 0 to infinity cos of cos omega x integration from minus infinity to plus infinity f of s into cos of, just a minute, I will confirm once again. Okay, cos omega x into d omega ds. This is what we get. Now you can observe minus infinity to plus infinity, this interval get restricted because of this, and it is restricted as minus infinity to minus 1 and 1 to infinity. The value of f of s is 0. Hence, this interval is restricted to minus 1 to plus 1. So hence we get 1 upon pi integration from 0 to infinity cos omega x integration from minus 1 to 1. F of s will be 1 minus s square into cos omega x d omega dx. Further, this is a even function, this is also a even function, and we are integrating an even function from minus a to a. So hence we can represent it as 2 times integration from 0 to a. So that 2 will be I'm taking outside. 2 upon pi integration from 0 to infinity cos omega x integration from 0 to 1 1 minus s square into cos omega s d omega ds. Further we integrate with respect to s. That gives us 2 upon pi integration from 0 to infinity cos omega x. Now the integration of this term is, this is my first function, this is the second function. This is a algebraic, this is a trigonometric. So 1 minus s square into integration of this, that is sin omega s upon omega minus the derivative of this is minus 2s. Integration of sin is minus cos omega s upon omega square plus derivative of minus 2s is a minus 2. Integration of this is minus sin omega s upon omega q. Limits from 0 to 1. So hence into d omega, this term remains is d omega. So hence this is 2 upon pi integration from 0 to infinity cos omega x into bracket. We substitute the upper limit as 1 here. 1 minus 1 becomes 0. 0 into this is 0. So this terms are going to be a 0. Minus 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 becomes minus 2. S is 1, so we get 2 there. Then cos omega upon omega square. Next, this minus minus becomes plus. S is a 1, so we get sin omega upon omega cube minus lower limit. The lower limit is 0, we substitute 0 here. Sin omega into 0, that is sin 0. Sin 0 is 0, so the first term is going to be a 0. Minus 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 becomes minus. We substitute s is equal to 0. 0 into this becomes a 0. Again, we are substituting s is equal to 0 here. So we get sin 0. Sin 0 is 0. So hence this is equals to 2 upon pi integration from 0 to infinity cos omega x into bracket minus 2 into cos omega upon omega square plus sin omega upon omega cube into d omega. This part remains. Now we'll just simplify the terms as 2 upon pi integration from 0 to infinity. By making the denominator common, that is an omega cube, sin omega minus 2 omega into cos omega divided by omega cube into cos omega x into d omega. So this is known as the Fourier integral representation of the given function, and this is a cosine integral as the cos terms is present, that is cos omega x is present. So this is all about the representation of a function as a Fourier integral representation. Now we are taking this concept to the next level, that is a Fourier transform. So in the next section we will discuss how to derive the Fourier transform of the given function. Thank you.